Good afternoon, everyone. I'm Teena Bell-Harris, and I'm a part of the eFormative organization, and I'm a part of the AgWind team. We want to welcome you today for our DWEA workshop, AgWind Energy. Energizing San Patricios County through AgWind, how to save money with rural wind energy systems. At this time, I'd like to bring to the floor Paul Charles, Director of RISE, who will give opening remarks and tell you a little bit about himself. Let's give Paul a hand.
Okay. Can everybody see me and hear me? Yeah. Okay, so my name is Paul Charles. I'm with Rise Energy LLC. I'm actually a local resident of San Patricio County, live in Portland. I'm here to talk to you guys about options for wind energy. We all know that the electrical grid is at capacity, especially here in Texas. I'm sure many of you experience blackouts. We're probably going to see a couple blackouts here over the next couple of days with this storm approaching. The great thing about wind energy is you can produce at the local at your port of use. Wind energy can help build resilience in the community. Works well even with the sun's not out. Today you'll learn a lot about different options using AgWind tool, including my company's off-grid models that work well for microgrids, EV charging, and lighting. Happy to talk with you on a one-to-one after the workshop and look forward to the specifics. Thank you. Have a picture?
Rowdy group. That's a rowdy group.
I wanted to apologize and invite anyone that's here locally that would like to give a few opening remarks. They're welcome to do so at this time.
I don't know.
Okay.
Me up there.
All righty.
I gotta get those one down out.
Okay. Just wanted to be respectful of the community. You're very welcome. Well, at this time, I'd like to take a moment to introduce to you a man with many passions, Mike Bergey. He's co-founder of Bergey Wind Company and is president and AMP CEO. Mike Bergey is a mechanical engineer and internationally recognized expert in the fields of small wind systems, distributed generation, and clean energy policy. Mr. Bergey is leading the world. His company, himself, and his organization is leading the world in manufacturing small wind turbines, installations in over 50 United States and in over 120 countries. Mike has twice served as president of the American Wind Energy Association, AWEA, and is currently in his 6th term as president of Distributed Wind Energy Association, also known as DWEA. At this time, I'd like to bring Mike Bergey up, who will give us insight on distributed wind for ag businesses. Thanks, Mike.
So Heather, can I stand here? Does that work?
Oh, that's great. Sure.
You can? Okay.
Maybe tilt the laptop toward you.
Okay.
Even better. Just take one step back. Oh, there you go. There you go. Perfect.
Perfect.
All right.
You're too tall.
Okay. All right, Teena, thank you for the kind introduction. My name is Mike Bergey. I'm president of Bergey Wind Power Company and also president of the Distributed Wind Energy Association. as Teena said. And I'm going to start by, eventually I'll get to distributed wind, but first I'm going to tell you about my first trip to Corpus Christi. There was an annual conference of the Texas Renewable Energy Industries Association in Corpus. I flew down and tried to get home that night, but there were thunderstorms and I couldn't get home. The problem with that was that the next day at 11 o'clock, my wife and I were headed to Europe on a combined business and vacation trip. I hadn't packed. And so she hung up on me a few times, but eventually packed for me and met me at the airport. I landed an hour before we left for Europe. And, so we'll see what happens tonight. She's, but I probably brought the storms in. That's probably my karma. So what I'd like to do today is to provide a primer on distributed wind, particularly for agricultural applications, talk about the very important federal policies that were put in place in 2022 that make the numbers work amazingly well for this technology, and to show you a tool that we have that will help our potential customers evaluate the feasibility of a number of different wind turbines from a number of different manufacturers and hopefully find something that works well for them. I don't have to tell you that the wind blows a lot around here. AgWind is here in Sinton because we wanted to focus on sort of the petrochemical zone around the Gulf and in places with lower income and with great wind resources. And so Patricia County is one of those places. And our overall goal is to make the people of the county and the surrounding areas aware of this opportunity. And with any luck, there'll be some small wind turbines to complement all the big wind turbines that you see driving around here. So with that, let me explain. Distributed wind is the use of typically one or two or a small number of smaller wind turbines, much smaller than the big units that you see, the multi-megawatt units. They're installed behind the meter and they're used to reduce electric bills. There's also a community wind, but the real opportunity is for people to own systems to reduce their utility bills. And it can be of all sizes. You'll see some examples here in a minute. I think within our trade association, the Distributed Wind Energy Association, we represent companies that have turbines from 50 watts on up to 1 megawatt. So that's a 200-to-1 scale. There are products to fit every need, and typically a distributed wind system is sized to meet the local load. So if you have a big hog operation, you're going to use a bigger turbine generally, or if you've got a smaller operation, a smaller turbine. There are a number of distinct advantages of distributed wind. I'll go through them very quickly. It's because the energy that you get from a wind turbine is very sensitive to the wind speeds. In the places where you have very good wind resources, like this part of Texas, the economics are typically better than solar. So it's a least cost option. Here, you don't have that many trees. You can site them very easily. We recommend 2 acres or more property, but then for the applications we're going to be talking about, agriculture, the property size are typically going to be much bigger anyway. You may or may not be aware that about 80 to 85% of all the solar products sold in the US are made overseas, mostly in China, although they have spread some of the assembly plants around to other Asian countries. But China has a very high dominance in the solar field, whereas in wind, there are both imported and domestic suppliers of smaller wind turbines. So you can buy American, you can buy stuff that's assembled here, you can certainly buy stuff that is supported here by companies who are expanding here in the US. It's complementary with solar. Of course, wind blows at night when there is no solar, but also seasonally, there's solar peaks in the summer and wind peaks in the winter. If you have both sources, you have a greater supply of clean energy. So they complement each other. And very important to the agricultural market is the footprint. So a solar array, that of course, the more energy you want, the more power you have to install, and the bigger the footprint, the more land that you take up. If you can fit it on your roof, that's fine. But if you're taking up land, you might have read in the paper, there's a lot of controversy now about solar conflicting with valuable farmland. Wind systems just have the tower. And it's very small compared to solar. It takes up far less space, and actually that small footprint plus a lot of people remember or have relatives who had wind power on the farm before the REA came through. We generally find that wind power is more popular than solar in the agricultural markets. With the new power electronics and battery storage, we can strengthen the grid. We can provide the resiliency that Paul was talking about. We can ramp faster. We can install much quicker than other technologies. And we also provide, particularly for corporations, branding of environmental stewardship. So we have companies like Swift's Farms, the hog producers, who are helping to put in wind systems to help with the branding of their products. The wind system, of course, is very visible. The large wind farms that you see around here are less expensive to install on a dollars per kilowatt basis, but they're selling into a bulk market. So smaller wind systems are more expensive than the big ones on a per capacity basis, but they're also selling into the retail market, not the wholesale energy market. So even though they're more expensive, what they produce is more valuable, and sometimes by a lot. I talked about the complementariness of wind and solar. This is a graph that's actually put out by the Congressional Research Service and shows typical daily variation in wind and solar and how they complement, and then seasonal. And that just puts some figures to the concept that it's a good complementary resource. I mentioned it, that there's a lot of manufacturing of smaller wind systems in the US. One of the things about solar is that it's highly automated, so there aren't that many manufacturing jobs. In fact, in China, there are plants that don't have any lights because there's nobody there to look at anything. It's all robotic and automated. Or they turn the lights off. They have lights, but they turn them off. Because of the lower manufacturing volume, the kinds of processes, machining, welding, painting, these are real jobs generators. So it's really good for the economy. One of the things that's important to bear in mind is the vast scale of difference between the large wind farm machines and the sizes that are suitable for rural homes or agricultural applications. You're sort of talking about something between 150 feet or 120 feet in diameter down to about 20 feet in diameter, and on towers that are 1/4 the height of the 1/3 to 1/4 the height of the large turbine. So they're much, much smaller. We classify the sizes as small, medium, and large, and I've listed on this slide, and we'll make the slides available, of course, but we've listed some of the major suppliers, a number of which are in the room today with us. But there are plenty of products to choose from on the market. I want to briefly cover a couple of examples. This is a Nebraska trucking and processing agricultural business. They put in a 15 kW turbine. It was installed by American Wind Power, installed in 2021, produced about 50,000 kilowatt hours per year. They got a USDA grant, took the credits, and they were able to get about a 2-year payback on that. And then this is this is a much larger operation, which put in 2 100 kilowatt turbines from Northern Power Systems. Haas Engineering put that in 2016, produced about 500,000 kilowatt hours per year, and produces about 60% of the dairy's annual energy. It's connected to a rural co-op, and in this case, not always the case, the co-op was quite helpful in getting that set up. The distributed wind has a tremendous amount of potential. In fact, it's on par with the potential of offshore wind. Many people find that surprising. And of course, most of the energy potential is here in the Midwest. So we do see a tremendous number of wind farms, you know, from Montana on down through Texas. Texas is the leader, of course, in the country in large wind. And that's because of the excellent resource and the amount of land here and the amount of consumption. But distributed wind, the government has done studies. They found that it's suitable in almost 50 million sites around the country, and is capable of doing 1.4 terawatts or 1,400 gigawatts of energy, which is about the total consumption of electricity in the US. And the potential, as we drive costs down, is even greater in 2035, and that's when the president has set a goal of having a clean energy grid. At that time, potential is more like 6,000 gigawatts. So distributed wind, which is not nearly as well developed as large-scale solar, small-scale solar, large-scale wind, has potential to grow tremendously. And one of the things that is also complementary is that solar works best in urban areas, smaller lots, more congested, and wind works better in rural areas where you've got more space because the towers and the turbines are relatively big structures. Over the last decade, the Department of Energy has invested tens of millions of dollars in improving the technology of small wind and medium wind. And so some of the costs have come down by over 50% and help to make small and medium wind competitive with imported Chinese solar. And that technology is still on the move. Stuff is getting less expensive, and some products are getting into higher production volumes, which is helping to drive the cost down even further. I want to switch gears now and talk about the opportunity that we have over the next almost 10 years. In 2022, the Congress passed the Inflation Reduction Act, and it provides enhanced tax credits with a long runway over 10 years. And most important, for the agricultural markets, it supercharged the USDA REAP agricultural grant program. And it did that in some significant ways that I'll be covering. First, let me cover the inflation or the investment tax credits. You start, if you've got a turbine that's under a megawatt in scale, you start with a 30% basic tax credit. And then there are bonuses. This is just for commercial, not for residential. There is a 30% residential credit as well, but it doesn't have any of these bonuses I'll mention. So the first bonus is a 10% domestic content bonus. So if it meets if the turbine meets a certain threshold, a percentage built in America, then, and it has 100% US steel for the tower, it qualifies for the customer gets an additional 10%. So a 40% ITC. In addition to that, there's another 10% bonus for if you happen to be in what's known as an energy community. An energy community is a place that has a high percentage of the local GDP or jobs that come from fossil fuel, plus it has an unemployment rate that's above the national average. And that, if you're in one of those, you get another 10%. And I'm going to show you that map in just a second. And not surprisingly, where we're standing is it gets that 10%. And then there are some additional 10 to 20% for low income communities. This has to be competed for. It really doesn't work for small projects. And so I'm afraid that one's sort of out of reach for distributed wind. These installations still qualify for the historical 5-year accelerated depreciation, double declining balance, MCRS depreciation, or if you have the tax appetite and can take, you haven't used up your section 179 expensing limit, you can take 100% depreciation in the first year. And so when you stack, you know, you could, the federal incentives are very robust. On top of that, you know, like one of those late night commercials, and that's not all. You can take, you don't have to have the tax obligation to use the credits. If you're a nonprofit, a tribe, electric utility, cooperative utility, you can get a check from the Treasury. You just file the tax, you get a check from the Treasury. If you are a for-profit organization, you can also get it monetized without having the tax appetite, but you do that by selling it to another corporation. And so typically, if you earn $1 of tax credit, you would sell that for 85 cents or 90 cents, and that's tax-free. So you don't have to be paying a lot of tax to benefit from the federal tax credits. And that is completely new and transformational. It used to have to go through tax equity deals that required legal bills of several $1 million, contracts a couple of inches thick, and just wasn't suitable for small installations. I mentioned the energy communities. This is the latest map. It changes every year, but you can see this is a zone that we're in. Only half of my state qualifies, and last year almost none of it did. So this is good. So down here you would get at least a 40% tax credit plus depreciation, and if you use something that met the domestic content requirements, would be 50%, and you could sell that to another corporation, tax-paying corporation, for 85, 90 cents on the dollar if you couldn't use it directly. So let's turn to the USDA program. And so what the Inflation Reduction Act did was increase the maximum grants from 25 to 50%, so doubled them. It put a lot of money into the program. It was typically being funded about $50 or $60 million a year. They put $1.7 billion into the basic program, and as you'll see in a minute, they put $300 million into an all-new category that we had been campaigning for several years, an underutilized renewable technology. The USDA grant program is a competitive program. You do an extensive, unfortunately extensive application, and it's scored, and about 25% of the score was based upon economics. Solar had the best economics, and so it was very difficult for someone who was putting in an application for a wind project to actually get an award. And so what they did was set aside a portion of the money for underutilized. So wind does not now have to compete with grain dryers and solar systems in that application process. And essentially, if you put together a qualifying application, you're pretty much guaranteed to get an award. And amazing thing about this is that they stack. So you don't have to reduce your federal tax credit that you earned by what you get in a grant. You don't have to reduce your grant by what you get in the federal. You stack them 100%, 100%. They also did, was just two application processes per year. They upped that to 4. And so it's really been a very active part of the distributed wind business. So I can't emphasize enough how important the underutilized technology fund has been to distributed wind. It's got a fair amount of money. It started with 145 million, and 32 million is added each fiscal year for the next 4 years. And so the underutilized technologies include wind, digesters, geothermal, and hydro, everything essentially but solar and grain dryers, efficiency stuff. And so, as I mentioned, you've got almost 100% chance of getting an award. Remember, up to 50% of the cost of the project, if you're put in an eligible and complete wind energy application. I won't kid you, the application is 60 pages, 70 pages. It's a mess. We've tried to get them to simplify it. We've had some success, but not enough. And some of the environmental stuff is getting more and more difficult. But quite often you'll find that a manufacturer or a dealer will help you with that application. You don't have to do it yourself. And there's a whole army of grant writers out there who are experienced with the particular peculiarities of a state review program, because they're not all the same. And so that service is available. Don't let the grant writing throw you off. So here's an example of the way that those subsidies stack. If you start with $110,000 installation for either a rural business qualifying for REAP or a rural home, the rural home just gets to 30%. So you end up at 77,000 as a final cost, and you have to have pretty expensive electricity and a pretty good wind resource to make those numbers work. But if you're an agricultural business, either a farm or a rural agricultural business, you don't have. If you're in a rural area, that will qualify, and there are maps online that will tell you whether you qualify. But you go with the 30% basic. If you get the 10% domestic content, the 10% community bonus, and you take the depreciation, the after-tax incentives, federal ITCs, about 42,000. When you add in the REAP grant of 55,000, which is only payable after the turbine is in service, you have to pay tax on that, but you end up ahead. It's over 100% once you take the depreciation. So it's an amazing incentive program, and there has been literally explosive growth in sales for that. And the USDA really wants this. There was a farm census report came out earlier this year that showed that 84% of small farmers had to take a second job to keep the farm going. They couldn't live completely off the farm. Secretary Vilsack cares a lot about small farmers. He takes a lot of heat for also being good to large farmers, but he does care a lot about small farmers. He came to our annual conference in Washington in February and announced RAISE program. It's really one of the worst acronyms I've ever seen. Rural Agricultural Income and Savings from Renewable Energy, RAISE. And so what you're seeing now, people often say RAISE, they never give the whole thing because it's just awkward. But what they're trying to do is boost rural incomes, farmer incomes for small farms, and so they're heavily promoting use of small wind turbines and medium wind turbines on farms. They have a very modest goal of only 400 systems in 5 years. They'll be ahead of that by the end of next year. So they'll increase that, but they wanted to have something they could, a metric they could meet. So that's a joint DOE USDA program, and it's starting to filter out to the different RD offices in different states. And then to complement that, DOE has a SEND program that is trying to get the word out about the opportunity. And so they're engaging with policymakers in the states and different organizations to try to make sure that they understand the opportunity here. And finally, I want to cover an important new tool that AgWind and the Distributed Wind Energy Association have just rolled out, and that is the AgWind Wind Report, which is an online and free economic performance and economic evaluation tool. I won't spend much time on it, but it works with a worldwide wind database from Vaisala, used to be 3-tier, and Microsoft Bing mapping or geolocating system. So you can put in an address or a Latin lawn anywhere in the country, actually in the world, and tower height that you want to use, and it'll give you the wind speed according to that database. Then you put in some other technical details of the installation, not that difficult really, and it will bring you back the wind speed at that site for that tower height, and it will give you a performance projection for an annual basis, not monthly, giving you the wind speed, the average power output, the daily, the monthly, the annual, and then the percent of the time that the turbine is operating, not necessarily producing very much power, but operating. And so so that's the performance analysis. Then there's also a financial feasibility part of this, and you put in a bunch of different parameters like whether you're going to borrow money, what kind of tax rate you're in, tax bracket, both federal and state, whether you can use 179D or the MACRS depreciation, whether you're going to borrow money, a number of different things, what's your electric rate, and that sort of thing. It already knows how many kilowatt hours per year the wind turbine's going to produce, and it will return the net present value, the internal rate of return, the lifetime cost of energy, and the payback period. We find that people are particularly interested in the payback period, and it'll show you a simple graph of in red what you would pay to the utility company over time with building no assets, and then what you will earn or save by buying a wind system and installing it. So, you know, with the high subsidy rate of the combined ITC and the REAP grants, you get these sorts of, 6 months to 3-year payback periods on products that will be producing energy for the next 30 years. So it's really, you build assets. We don't recommend leasing these things because then the leasing companies get the real benefit. We think for farmers, you should buy them perhaps with a loan or cash because that gives you the best return and builds your asset base. The manufacturers in the tool, there's a drop-down menu. You can pick the models. The models are pre-selected for whether they're certified. Certification provides not a guarantee, but certainly a indication of the quality of the engineering and design that went into that. Certification is a $100,000 to $200,000 process that a manufacturer has to go through. It's not a simple thing. There are only certain labs that can do that certification. And so DOEA has decided that we'll only model the turbines that have pass that certification. These are the manufacturers. Several of them are in the room, and it spans a size from about 160 watts on up to a megawatt. As more turbines are certified, we'll be adding to the tool. And then finally, I'll just point out that there is a sign-up sheet out on the table that you can put your information in, and we'll run you an analysis. In fact, can do for multiple turbines if you'd like. For further information, I recommend resources of agwindenergy.org, which is a particular program of DWEA, which we have some support from the U.S. Department of Energy and now the USDA, and then the association distributedwind.org, which is our national trade association and their website. And with that, I want to thank you for your attention. I think we're going to do question and answers at the end.
Yes. Thank you so much, Mike. And now at this time, I failed to mention that our team in this event today has dual locations, maybe more than 2 locations. We're here in Sinton, and at this time, we've got a representative, Edgar Alvarez, that is in Texas, upstate Texas, and I'm going to spend a few minutes to tell you a little bit about him. He's a team member from USDA. Edgar was born and raised in Puerto Rico, farmer's family, has a BA in business and an MBA in finance. He has over 20 years experience in compliant roles, has worked 4 years with SBA, and has transitioned in the USDA to join the Texas Business Cooperative Programs, including the Energy Texas team. He currently is USDA Business and Cooperative Programs Manager, Texas Rural Development at the McKinney office. At this time, I'd like to introduce to you guys Edgar Alvarez. Okay.
Hi, good afternoon. Thank you, Tina, for the
You're
introduction.
welcome.
Hi, my name is Edgar Alvarez. I'm part of the team of State of Texas on the RD Rural Development and the Rural Energy for America program. Part of the team we are here today is Vicky Telton. She's the Texas Energy Coordinator, and Maurita is Spivey is in our team as the grant management program, and myself on the Business Cooperative program. Thank you, DWEA, for the invitation. We're glad to be here. We're going to share our kind of highlight level of the REAP, but we're also going to provide information, detailed information about the program and the grants, and also the guarantee loans that we have that we can include as part of the REAP IRA program. As Mike mentioned, I'm gonna kind of complement a little bit about what Mike mentioned before with the IRA, and as he mentioned, the main program is $2.2 billion that we the government add to the program, and as part of the REAP we have 1.7 and then 304 million that we're using for underutilized technology and technical assistance, as Michael mentioned before. Here's the part that we like to kind of concentrate a little bit more is on what kind of financial assistance we have at the REAP under USDA, under rural development. Grants is a portion, is one. And then the second one is a loan guarantee. We do have a program, a business program, the guarantee up to, in cases we have up to 80%, or in cases of REAP, we have up to 75%, but 75% guarantee loans. We use different lenders. We don't use a specific lender, but we have a list of lenders where applicant can use their own lender to use that kind of type of assistance. And also we have a combination of grant and loan, and we're going to show you later a little bit more information. What kind of REAP project type? We have what we call the renewable energy systems, okay, and then we have the energy efficiency improvement program, and then the third one is the energy efficient equipment and system that we call the EEE for agricultural production and processing. This is more than the loan guarantee only program. How we are part of the REAP grant funding, how it separate from the program. And we have the first part, which is the system installations. We have renewable energy system and energy efficiency improvement. And then the second part of this is that we have a technical assistance plan. We do partnership with different entities in energy audit and also in renewable energy development and assistance. How to give you the the technical side and help you how to complete applications, to give you general information about the REAP program and grant, more on the grant side. System REAP system and equipment and improvement. Like Mike mentioned before, we have grants. It's going to cover 50% of the total project on the grant side, and from 25% of the pre-IRA. And also we have the loan guarantee on loans that cover up to 75% of the total project. And you can also combine both. I mean, you can have a portion of the loan of the grant that you go in the reward, it go up to 2 million on the total project cost, which is 50% will be 1 million on the grant side. And then in the loan side, you up to 25 million as a REAP guarantee loans. This is kind of the second part of the IRA program, which is Mike mentioned before, and then the fund is 144 million, which is available or added to the program. This is we're gonna be talking about now about how the competition is done. I mean, we already complete, as you see here, we already complete several windows of the applications. Right now we have open, is still open, which is we call it the June 30, 2024. It will be the next one, and which is open in July 1st. And the last one of the year will be September 30, 2024. And this is part of the IRA program. We don't know what's going to happen, but for now, this is the two windows that we have right now. It might get extended, but we don't have those details right now. Who is eligible? I mean, under the REAP, more a rural small business. It will be the primary eligible group, and how we describe the rural business is we use the SBA size standard for a small business, and it could be a private for a profit entity. It could be a cooperative electric utility, or it could be a tribal corporation or tribal business entity. And important located in the rural area or non-metro community, less than 50,000. What is the second group that is eligible is agricultural producers. For an entity or individual or entity that receive 50% or more of the gross income from the agricultural operation. It could be crops, livestock, aquaculture, nurseries, and dairies. How this is the next part. This is the kind of the very important part of the process, because we need to make sure that how you're going to be eligible based using the address of the location of the project. And David is going to provide you in the chat the link that you can use to make sure that the area is eligible under our program. what type of project are available on the REAP? And this is kind of interesting because on the REAP there is a solar portion, wind, which is our kind of the main objectives today, the main topics today. And then we have other areas that is available for under the REAP, which is a small hydroelectric, anaerobic digester, biomass, geothermal, and also ocean power. And the other part of the I mentioned before is the energy efficiency projects, which is include lighting, heating, cooling, ventilation, fan, automatic control, and insulations. What funding is available? Under the REAP grant, as I mentioned before, is up to 50% of the project cost. The minimum that we use in the minimum total products is 10,000, and the maximum grant request is 1 million. Under energy efficiency improvement area, we're using as a minimum 6,000 of the project cost, with a maximum of grant up to $500,000. RISE program and technical assistance. Here's a part of the, as Mike mentioned before, we partner with with the Department of Energy and us, USDA, and in how we're gonna promote this program, how we're gonna outreach this program. And one of the key part of our kind of partnership and an agreement is the technical assistance. We have partners across Texas that it's gonna help the applicant on the technical assistance. It's gonna support to use applications, and then complete the how to complete energy audits, talk about environmental reviews that they need to be in compliance. And for that, we're kind of gonna give you the more later, going to give you the information of the technical assistant that we're using in Texas as a primary resource to help you to complete applications, and including wind and other programs. This is kind of high level of the RISE and then the Department of Energy partnership, and then how distribute to wind customers. This is a presentation that was provided by NREL, and also if you look at the chat, David is going to send you a good webinar that NREL is promoting. It gives you a lot of details about the technical side on the technology of the wind, on the wind technology that we're talking today. I mentioned that before, wind turbine sizes. This is a little bit general information how the technology works, and some of the benefit that and description of the wind technology. All right. On the REAP side, and on the purpose is just identify those areas, and then make sure that where is the project is going to be located, and then how is the project is going to be eligible. So it's a step that need to follow, but we're here to help. We're going to provide you our information at the end of the presentation, and then we can walk you through the general overview of more detail of the program. Here's a technical assistant for REAP, and if you take a picture, we're going to provide this presentation of for the audience, but Mr. Joshua Partipin, he's part of the West Texas NAM University, and he's the associate professor of engineering technology in the Rural Energy College of Engineer, and he's one, and the team, their group is part of the the partnership that we have with in Texas for the technical assistance for REAP. We're gonna give you we a couple example of the REAP project that we
Yeah, I'm sorry, I'm not sure we have time for all of this today. If you have one on wind, go ahead for the examples.
yeah
For all the other technologies, we don't have time for that today. Thank you.
right. Yeah, the most important part of this one is the combination of the REAP grant and total loan guarantee loans and the REAP grant that we use in different projects. I'm gonna continue with all different projects that we get involved, and we would like to see more wins projects in our side. But for now, we see a lot of these. Like this one's a good example of the REAP total project and REAP guarantee, BNI guarantee, and then we call it the combo sources, combo grant and the guarantee loans. And for the loan side, for the guarantee loan, so we mentioned before, you can use the grant side, and you can request a loan for your project, minimum 5,000, and the maximum request you can do of up to 25 million on the REAP. You can also, if the project is higher, you can also explore the option of the BNI, which is part of our program. That's going to add you more money of funds, loans, if the project is more than 25 million. And how you can apply? We're going to give you these links here. That's part of our Texas Rural Development. And also, we're going to provide you our information here and emails in case you have any questions. We can walk you through. We can do one-on-one. We can do Teams meetings, and also we can provide information about how to apply, and then general information about guarantee loans and any regulation or question they might have.
Great.
Any questions?
Fantastic, Edgar. We appreciate all your information and your knowledge. It's outstanding, very complimentary. And next, you guys, I'd like to introduce to you Andrew Robinson. Andrew is a program manager at Texas Energy Poverty Research Institute out of Austin, Texas. His work focuses primarily on addressing energy affordability issues and increasing access to clean and reliable energy for low-income and underserved communities. Although based in Austin, as you can see, Andrew's work is US and even global wide. He primarily focuses on South Texas, the lower Rio Grande Valley, and the coastal bend. Let's bring up Andrew Robinson.
Alrighty, so I'll just take 1 second to get set up here. Alrighty. So I appreciate y'all's patience, and I'll keep things more or less pretty brief. I know I'm kind of standing between you and your evening before a holiday. But again, I'm Andrew Robison. I'm with the Texas Energy Poverty Research Institute based out of Austin. Just to tell you a little bit more about us, we basically do anything and everything that advances solutions for affordable, reliable, and clean energy for all Texans. And that looks like a lot of things. We do straight up research. We just did a survey of 6,500 households across the state to better understand how do people feel about energy generally, how do people feel about renewable energy, whether or not their energy is affordable, whether or not They feel that they can rely on their energy systems to better understand what motivates Texans when it comes to energy. We also help develop tools. We have our own internal tools, which I'll show you a little bit about later, and also work with others who have developed great tools like AgWind. And then we also do pilot projects on the ground. So we work with community organizations, local governments, really whomever is interested in developing energy solutions that help benefit underserved or low-income communities. These are just kind of some statewide statistics. I won't go too in depth here. But basically, our organization is motivated by reducing energy costs for households that need the most help. As you can see, the average income, the amount of average expense for people who are making well below the poverty line is 15% of their income towards electricity costs. So we're really interested in addressing all of the red areas that you see here. So this is a map of the census tracts in Texas. So basically, Census Bureau breaks down geographic areas into chunks of households that average about 4,000 people each. So we're really interested in addressing what we call energy burden, or the percentage of income that is spent towards that a household spends on energy costs. And so our work takes us all over the state, but as you can see, we're primarily interested in the communities that are the most affected by high energy costs, particularly those where incomes are somewhat lower. And this just kind of shows you kind of where people in the state are struggling the most as it relates to energy costs. But as you can see, this statewide map doesn't really paint a very clear picture of what it looks like in urban areas. So I just wanted to show you, this is sort of a lot of the data that our internal data allows us to use in order to help local governments and community-based organizations decide on how to allocate resources, put together federal grant applications, really anything as it relates to better understanding how communities, how energy burdens differ across different communities and even within communities, as you can see here. On the left, we have San Antonio, and on the right, we have Webb County, which is Laredo. So you can see, like, even within a given community, you can't paint, one single conclusion about energy affordability. It really differs from place to place. And so that brings us to here in San Patricio County. As you can see, I think our organization was really motivated to be a part of this AgWind opportunity, given the fact that, as we all just saw with the various federal incentives and newfound affordability as it relates to wind in specific cases, there's a really good opportunity to help reduce energy costs for folks around San Patricio County. And I don't really have too much to say about this map in particular. I just thought you all might find it interesting to kind of see how average energy burdens differ across the county. You can see there's certain pockets, particularly within the more urban areas, Aransas Pass, Taft, and Mathis, where households are struggling a little bit more as it relates to energy costs. So yeah, just thought you all might find that interesting. And then here's kind of the dollar figures behind that map. So the average household in San Pat County spends about $2,600 annually on energy costs, or roughly 6% of their income. Our organization considers anything 6% and above to be unaffordable or energy burden, and anything 10% above to be extremely energy burden. So you can see for the average low and moderate income household, which is basically someone making 80% or less than the area median income, their average energy burden is closer to 11%, which is quite unaffordable. And even though their average annual energy costs are lower than the average household, that's still a much bigger portion of their annual income. So something to think about. And so our data tells us that within the area, there's about 10,000 households that have an energy burden of 6% or above. So that basically just shows you there's an opportunity with wind, potentially for some of these households to help reduce that energy burden and bring it down to a more affordable level. And with that, I just want to keep it real short. I think there's, others have said there's many fantastic opportunities as it relates to distributed wind. I just really wanted to urge the fact that we're in kind of a once in a lifetime point in history as it relates to the investments in renewable energy, but particularly here on the wind front. I think we're right at the beginning of a huge wave. I think the future is